Okay, it just turned 10 on the computer, so we'll go ahead and get started. Thank you all for being here. Does anyone have questions on chapter 4 before we get started? Or I think that's what we just finished. Or whatever we just finished. Okay, so, well, first we'll go back and look at that. So these are the 3 standard ways that we write division. They don't mean anything different than each other, but we will learn different ways of expressing division. So there's 2 ways, but 3 ways to write it. So we write A divided by B, or we have this A/B, for example, but still A divided by B on the keyboard. And then we have the one we kind of write when we do long division, which looks like A divided by B in a much different way. So in all of these versions, the one that gets written most incorrect is that last one, because the position seems switched a little compared to the others or something like that. But I suppose if you tipped the B and A sideways, like kicked it up, then so that that division looked like an L shape, then you could get it to look like a fraction. So let me show you what I mean. That's the one thing about paint, is you can actually just show someone what you're trying to imagine. Okay, so let's take that and rotate it. I think this way. There you go. So if you kick it that way so that the bar, division bar, looks like an L kind of, then you've got your A over B, sort of, right? So I don't know. You got to make your brain do that though to see it. But you know, that's just stuff that you practice until you get it right. Okay, so what we're looking at just the vocab a little right now. So we've got the divisor, which is your denominator. You've got your dividend, which is your numerator. And then the result of which is called a quotient. So when you see these 2 together, married with that symbol, you are looking at the quotient, because the result is the quotient. Standalone, A is the dividend. The piece being divided into is kind of how I think of it, right? Dividend going into and dividing. Okay, so then B is the divisor, the person, right? Because the OR, the person to which who is doing the dividing. Okay, and I do use these vocab words. Another thing I wanted you to see that people ask about is what age group are we talking to, right? And so generally the book will tell you, right, that you're looking at grades 3 and 4, and then the higher level conversations are for grade 7. We don't talk about dividing by negatives or anything like that. So that's like that group of individuals there, the 7th graders. Okay, so let's go to here. And this is the homework that you have to work on for chapter 6, well, for this week. And chapter 6.1 is about the 2 styles of division. Well, interpretations is what how the book is wording it. Okay, so let's start with the definition of multiplication, because that's our anchor into division. Okay, so the definition of multiplication, which you should be getting comfortable making yourself use. We've got A times B, and A is the number of groups. B is the number of units in one group. And then C, your, I almost said quotient. Here, that's a product, right? Multiplication. Okay, so we've got the number of units. They say in A groups, I say in total, right? Okay, so that's our definition of multiplication. And we need that because we have two versions of division. So the interpretations, oh wait, what do they call it? They change the word on me all the time. Sometimes it's perspective, right, is what the book calls it. Your book's calling it interpretation, I think, this year. Let's see if I can find it again. Yeah, interpretations. Okay. I just want to use your book's words so that I don't confuse you. Interpretations. Okay, so let's put our frame in. This is our tool right here. Now, you're always going to know C because we're either looking at a C divided by B situation or a C divided by A situation. And we don't really know which one it is until we put it in the frame, right? Like these are just two numbers at this point. But the divisor in the first one is known to be the number of units in one group. So the thing you're looking for is how many groups. And that's the book's version of this interpretation of division. And in the second situation, we know the number of groups that we're trying to divide by, but we don't know how many items are going to go in each group. So we have the how many units in one group perspective interpretation. So I'll call it style of division, perspective, here interpretations, right? That's what your book is calling it. Now, these go by other names. So if you look up other resources, even in your book, it brings up the name of these other ways of referring to these perspectives. The how many groups perspective is also called repeated subtraction. Because you know how many things go in a group, and you know how big your pile of stuff is. So you just keep taking that much out over and over and over and over again until you can count up the number of groups that you have. So repeated subtraction is that one's other name. And the how many units in a group perspective is also called partitioning. Partitioning. Because you've got just like this pile of stuff, and you know how many groups you want to put it into. So you just like evenly divide up the stuff in a partitioning type of way, right? So you just take the stuff, you're like, okay, I'm going to make you into 4 groups. And then you count up how many things are in a group. So those are the 2 interpretations of division. We'll take a look at a couple of drawings then, right? And please let me know if you have any questions. Let me put that back up while I drink my coffee for a second. Okay, so yeah, the book's new edition looks a lot better than the last edition because I've got them side by side right beside me here. And one thing I noticed is they're using A and B and not M and P. M, N, and P is what they used to use instead of A, B, and C. Okay, so let's look at not necessarily an example. Let's see. There's, okay, sorry. I just have so much to say about it. I don't want to leave anything out, but we'll just start. Okay, so we'll look at a couple of same numbers, different situation thing, like a quotient that's 20 divided by 5. And we'll try to represent it in the 2 perspectives, right? So one interpretation was how many groups. The other one was how many units in a group. I'm usually then pretty good at picking up on the group part to recognize in the first case, I don't know the number of groups. In the second case, I do, right? That helps me at least get the anchor for our definition of multiplication. So our first perspective is how many groups. So when you're asked to write word problems, you need to know at least what you're asking and what you have, right? Like those things have to come up in the problem. So we know we have the product here, and we know that the 5 is the number of units in a group. So however we want to word this, generically, this is number of units in one group for our 5. And for our 20, we're going to have the total number of units. Now, in this class, we stick with whole number division. And then in the next class, you do fractions and decimals. However, we do have to look at those styles of remainders. So like, what does the fraction remainder mean? What does the whole number remainder mean? What does the decimal remainder mean, right? Like all of that kind of stuff that comes up in 6-2, division fractions, division and fractions, and division with remainders. So we do talk about it as an answer, decimals and fractions, but we don't talk about them as our factors and our product here. Okay, so our first question, I usually try to do something school related, right? Like chairs and tables or students and, something like that, candy. But okay, so let's write a word problem. We've got 5 things in a group, and we know how many things we have. We just don't know how many groups that we have, right? So we have 20 pencils, and we are giving each teacher 5 pencils. How many teachers can we give pencils to? Right? How many teachers is really the kicker, because the teachers are the groups, right? We could have said classrooms or something like that. Okay, you could have said students, right? But I imagine we gave 5 to each teacher, and then they gave people pencils who needed them or something like that. Okay, so one thing that the book did was upgrade the imagery in this chapter. So I definitely think they did a better job with chapter 6 in this new edition. So for sure, take a look at that. One way that they've drawn this situation then is, again, we know we've got 20 pencils, right? So we're going to just like lay out our pencils. 1, 2, 3, 4, 5. We know we're going to group it that way, so I'm going to put a little space there, but 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And then did I just keep going? I think I just kept going. 5, 10, 15, 20. Dang, I brought an extra 5 pencils to the table. Sorry about that. I was like, let's keep drawing pencils. Okay, so then what the book does is they put the grouping. Oh, sorry, I had the eraser on. They put the grouping of our one group information that we have, right? And they label that to be the one teacher, one group, right? So we would say that this is like one teacher, and they don't use an equal sign. They use something like double-sided arrows. That's an if and only if symbol. If you're in logic, right? Okay, so one teacher is equivalent to 5 pencils. Their label, of course, is right under the grouper, but I don't have that space. Sorry about that. Okay, do not, well, they do not continue the drawing beyond this, right? Of course, if you're in your classroom and you're actually talking to little kids, the point would be to now circle all of them, right? But your job in this class is to show the problem as a picture, right? And that's the problem as a picture. Now, if you want to copy and paste that somewhere else and then finish what your thought was to circle everything and have an answer, go for it. But you have to produce the situation imagery and have it be able to still be there after you've done other work on top of it. So just a warning. A lot of times this class isn't about answer, it's about the setup, right? And like, do you understand the setup itself, that this situation is asking us to find the groups, and we're going to take this little red circle, right, and put it over. Oh my gosh, my counting is terrible there. There's a pencil missing there. Okay, now I think there's 20 pencils, but all right, on the next one. So let's move on. And please interrupt me if you have questions. On B, I usually label them A and B as a secret nod to myself that I'm looking for A in the first one, and I'm looking for B in the second one. But you can't just call them perspective 1 and perspective 2. You have to call them by their names, right? And this one's name is how many groups. So let's at least put that one there in a more clear manner. So, and I usually put the parentheses around it. They put a dash between every word because it's like the name of the group. Okay, so on this one, on the second one here, moving on, we've got the end part. We always know the total that we're working with. We just don't know where the 5 goes, right? This time the 5 is the number of groups that we have. And we don't know how many items are going in each group. So this one is, we know how many groups, so we have 5 groups. We don't know how many units are in one group, but we do know how many units we have. Okay, so this time around, we have 20 pencils. And there are 5 teachers. How many? Pencils. My brain always interrupts and tries to get all the little like nooks and crannies, right? Because like giving them out evenly, and you're not trying to give one teacher 1 and the other teacher 7, right? Like that type of thing. So try to write a simple word problem without all that like brain interruption. Although your brain doing interrupting like that is how the kids are going to respond to your question anyway. So don't just ignore it, but try to anticipate those type of questions from little ones, right? If your own brain is doing it, you know their brain's going to do it too. So how many pencils does each teacher get? And then all the brain stuff, assuming we give the same amount to each. And now, one thing I try to avoid, and again, it's just a my brain type of thing, but I'm always trying to not use math words as regular words because I'm trying to emphasize math vocabulary as math vocabulary. So I don't say an even amount because even in math means something. And so I tried to reword it so that the concept of even was there, that they get the same amount, but it's not even the way we use it in math, like multiply by 2 type of stuff, right? So that's another thing. I try not to use words like add or even when you're trying to describe something in the context of a math situation because it can muddy the waters. Okay, so the picture they draw for this, and they have little dots. I'm just drawing sticks because they're pencils and it kind of looks like a pencil. Okay, I'm going to spread them out a little more this time. But we're going to go 1, 2, 3, 4, 5, 6, 7, 8. Y'all don't want to hear me just count, right? Okay. Okay, I think I got 20 there. Now, the imagery that they put on this, we're going to take our red ring again. We're not going to put it on the pencils this time. We're going to put a ring above the pencils. Oh, wait, I think I'm doing it wrong. Hold on. Let me back up. It's because we have to make our drawings secretly look perfect. So we actually have to think out what the answer is. In order to get 5 teachers across here, right? We actually know they're each going to swoop up 4 of these. So that's part of it, is like you've got to secretly know the answer while you're making a drawing that helps you understand how to solve it. Right? I like this. I'm gonna butcher it for a second, but I'll take those lines away. I'll put their labels on in a second too, but I like this. It's definitely new to their drawing type of thing. Like I said, chapter 6 looks way better in the new edition that you guys are working out of. Okay, so we partition in that we know we have 5 groups. And so if this was a number line that we had drawn, we would have our number line, right? Like going through the hatch marks here with like a 0, of course. We would have this number line, and then we would try to partition it in such a way. So the way I've drawn it, we can kind of pretend a number line right on top of it, but I have tried to also draw it the way that the book drew it for you. Okay, so Let me erase that yellow stuff. Oh, that's not the eraser. Okay, so we've written a word problem for each. The way they have labeled this, and they did label it on the left side, but I've got stuff on the left side. So I'm gonna label it here and say that, oh, it's so weird. It's like the same label, only it's going down. Except we don't know. So here they just have like one group. And we don't know how many pencils that is. So okay, so definitely I kind of like number lines as well, right? In terms of these two being drawn in a number line, then let's look at that. Which we, like I said, we've really mimicked here well because we had pencil marks as our lines. The pencils themselves. Okay, now just to match our idea of like this one being repeated subtraction. Which is our how many groups? You've got your number line, right? Surprise, surprise, I drew too big. Okay, let's see. 1, 2, 3, 10. Okay, so we know we have 20. This is for our first drawing, A. And I'm going to use the red as our grouper again. This time we are taking 5 out every time. To take 5 out, that means you start at the 20 and then you remove 1, 2, 3, 4, 5 of these pencils. Right? And now you're here. You remove 5 more of those pencils. And then 1, 2, 3, 4, 2, 3, 4, 5 more. And then finally 5 more. So I like this drawing because we get to see the repeated subtraction and how many groups there are, right, type of thing. But the repeated subtraction is us getting less and less and less and less on the pile, right? Now, let me erase this, just the red bits. If you want, you could draw another number line under this one or under your B stuff. Our B is our partitioning. Perspective, which is called the how many units in one group perspective. This one adds up. So not really. It's just that's what the arrows are going to look like when we're done. Okay, so and this is where, again, you, the adult in the room, know where to stick the partitions, right? So this time we're looking at it like we have this amount here, and now we're just going to split this into 5 equal groups, right? When it's a 4 or something like that, so then it's easy. You cut it in half, you cut it in half again, and you can do it by just partitioning it. When it's a group of 5, like I'm going to want to plan that out a little so that it looks good in the end, right? And so you can't just cut it in half, and then wiggle the ends. You kind of want to definitely make sure you're over the 1, 2, 3, 4, right? And cut it at least in ways that are going to line up for your students in the end, right? There's another 4, 1, 2, 3, 4, 1, 2, 3, 4. Now, if our students saw that without us telling them how we were already using the answer to be able to draw it, then this is what we're doing. We're taking the amount that we had, and we're just cutting it into these 5 equal parts, right? And it just coincidentally lines up with these marks here. And then often the arrowheads go this way versus the repeated subtraction where the arrowheads are reducing the amount that you have here. But like I said, if we had been divided by 4, then we really could have just cut this group in half and then cut them in half again. It's when we try to do it with odd numbers that it's a little more like you got to go in prepared, knowing how you're going to represent the visual. So that's a number line version, right? What are we dealing with? 20 divided by 5. Okay, so we also have array models. We have area models. We have multiplicative comparison. I was doing good, then I got too confident, I think. Okay, I was definitely didn't know if I had another eye to stick in there or not. Okay, hold on. Okay, so multiplicative comparison. Let's do that one first. That's the type of graph or whatever drawing that looks like a strip diagram. So we'll have 5 times as many somethings. But notice what we have is 5 groups. So clearly this is 5 groups in multiplicative comparison. And you don't know something about the one group, right? Like how much is in one group, for example. Okay, so we've got, let me make this look a little different. Okay, so in terms of a word problem or which model of division we're using, right, in terms of which interpretation, which perspective, we know the number of groups. What we don't know is how much stuff is in a group that gets us up to 20 of those things, right? So I usually call them items per group. So, for example, we could say, my brother has 5. Hold on, I was really about to write multiplication comparison. I just got to make sure I'm not writing it wrong. Yeah. Okay. Okay. Okay, so let's try starting with the answer. It'll maybe feel more like division. It's weird to call it multiplicative comparison and then also division, but it's because they're opposites of each other, multiplication and division. So my brother has 20 snails. Which is 5 times more than me. I'm sure we could write this eloquently, but my brother has 20 snails, which is 5 times more than me. How many snails do I have? I'm the group, right? The imagery shows that we have 5 groups. So we are saying how many in one group. You're saying how many does Angel get, right? Versus how many does her brother get. So this one is the me, and this one is the brother, right? And then this has a quantity of 20 snails. And we would go about taking the 20, dividing by the 5 parts, putting a 4 in each of the parts so that we could then say that the me person has 4 snails, right? But again, we're not after the answer here. We're after the whole setup. Like, do we understand the situation? Can we draw the situation? Do we know if we're looking for the number of groups? No, because we drew a strip diagram that's based off of groups, right? So you're definitely doing the how many units in one group perspective. How much is in one group is how I said it. Okay, let's look at array model and area model. So 20 divided by 5 as an area model. Let's see. You've got, if we drew it, you've got a room has an area of 20, I'm just going to call it square feet. One side of the room you hear my dog snoring, is 5 feet long. Question mark. How long is they said adjacent side. And you could definitely word this however you wanted. If you wanted to say you were looking for the number of groups, then you could word it that way in your multiplication form. If you wanted to say you were looking for the number of squares in each group, you could write that in your form. So it's up to you which way this one goes, which interpretation of division. Okay, and then the last one before you head out is 20 divided by 5 as an array model, which is similar to the area model, except that you really are talking about like rows and not knowing like how many are in each of your rows type of thing. So we know we've got 20 of something, right? So here I'm going to say candles, right? And you got 5 rows. So we have a box that can fit 20 candles, starting with the big pile. And it fits 5 rows of candles. That's the number of groups. So you're asking them how many items go in a group, right? How many candles fit in each row? Question mark. Okay, so you're welcome to take off. Thank you so much for being here. I will see you Wednesday and have a nice one. Let me know if you have questions. For the exam, no, I've graded half of it, but also I'm waiting for a couple of people to take it. So I've been trying to put it off until I get those. Thank you.